relations. Now let's see what it is. Let A and B be two sets. A relation from A to B is a subset of A cross B. This is the Cartesian product. Okay. Then R is a relation from A to B if and only if R is a subset of A cross B. So if X comma Y is a member of a relation set, let's say R, we say X relates to Y, or we say X is in relation R to Y. In short, we say X comma Y belongs to R implies and is implied by X relates to Y. Let's see with an example. Let's say we have a set 2, 3, 5, 6 and R means divides. Okay. So we can say 2 relates to 2. Why? Because R is divides. So 2 divides 2. 2 divides 6. 3 divides 3. 3 divides 6. 5 divides 5. 6 divides 6. Then we can write R as a set with ordered pairs. 2, 2, 2, 6, 3, 3, 6, no, not 6, 3, 6, 5, 5, and 6, 6. A binary relation, a relation R between pairs of elements of a set. So you have a single set and we are saying the relationship between the elements of that set itself. Let A be any set and R be the set of all pairs X comma Y of A cross A, for which X equal to Y, where X comma Y, for all X comma Y belonging to A. Then R is called the equality relation in the set, also called diagonal relation of A and denoted by, therefore, delta is equal to an ordered pair X comma Y, where X comma Y belongs to A and X is equal to Y. So if you look at it from a matrix point of view, yes, you would have something like this: 1, 1, 2, 2, 3, 3. Rest all will be 0. That is why it is called diagonal relation. Let's see another example for a relation. So A is equal to, let's say, 1, 2, 3, 4, and B is equal to 3, 4, 5. Now let's do it the long about way. Let's actually figure out A cross B. Okay, so you will have ordered pairs 1, 3, 1, 4, 1, 5. Then 2, 3, 2, 4, 2, 5. Then 3, 3, 3, 4, 3, 5. Then finally 4, 3, 4, 4, 4, 5. Now the relation says relation is less than. So R would be equal to what? Now look at each of the ordered pairs and check whether the first element is less than second element. So 1 is less than 3. Yes. So include it. 1 is less than 4. Yes. 1 is less than 5. Yes. 2 is less than 3. Yes. 2 is less than 4. Yes. 2 is less than 5. Yes. Now 3 is less than 3. No, it is equal. So we can't write that. 3 is less than 4. Yes. 3 is less than 5? Yes. 4 is less than 3? 4 is less than 4? No. 4 is less than 5? Yes. So this is the relation. Now here, domain of R is set of first coordinates. So 1, 1, 1, 2, 2, 2, 3, 3, 4. So that is equal to 1, 3, 2, 3, 4. And a range of R is equal to, what do we have? 3, 4, 5 is repeating everywhere. So 3, 4, and 5. Okay. Now, if A and B are sets containing M and N number of elements, then A cross B will contain how many? It will contain M times N ordered pairs. So here itself, if you notice, we have 4 elements here, 3 elements here. So we should have 4 times 3, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So therefore, total number of relations from A to B is going to be 2 to the power of 2mn, 2 to the power of mn, since each subset of A cross B defines a relation from A to B. Of course, this would include the null set and the universal set. So these are, because this is applicable in every case, these are called trivial relations from A to B. Okay. Relation on a set. If A is a non-void set, A cross A is called a relation on set A. Inverse relation. Let A and B be sets. R be the relation from A to B. The inverse of R, denoted by R minus 1, is a relation from B to A. So R inverse is equal to B comma A, where A comma B belongs to R. A comma B belongs to R implies and is implied by B comma A belongs to R inverse. Now domain of R is equal to range of R inverse, and range of R is equal to domain of R inverse. In the previous session, we have looked at functions. So let's understand what is the difference between functions and relations. So a relation is a mapping between elements of the same set or elements of different sets, whereas a function is a relation with specific characteristics. So what is that difference? The difference is that, if you remember, when we are talking of function A to B, we said that an element of the domain cannot be mapped to more than one element of the codomain. Yes. Whereas the above is not the case for relations. So what does this mean? It means a function is a relation, but not all relations are functions. So whenever you have something like this, let's say you have y is equal to x square is a function, right? Whereas x square plus y square is equal to 1 is not a function, but both are relations. Now, if you look at it graphically, you will realize the difference. This graph goes like this: y is equal to x square. So here, if you draw a vertical line, you will notice the vertical lines cross this curve of this function only once. Vertical lines cross the graph or the curve only once. Look at any one line. It will cross only at one point. So therefore, it's a function. Whereas if you look at x square plus y square plus is equal to 1, that's the circle, right? So here what happens, if you draw a vertical line, you will notice that each of these vertical lines crosses the curve, the graph or curve more than once. This is called the vertical line test. Okay, now in previous sessions you might have heard about horizontal line test. Okay, that is purely in terms of functions where to figure out whether it is a one-to-one or many-to-one function, right? So if it is one-to-one horizontal line test, now in case of one-to-one horizontal line test, what it would show, that in case of one-to-one, the horizontal line crosses the curve of the function only once. Yes. So let's say we have a graph of y is equal to 3x plus 2, something like that. So maybe it goes something like this. Okay. So here you notice that if you draw a horizontal line, it will only cross the curve once. Now, in case of many to one, the horizontal line would the curve more than once. So here again, let's go back to the y is equal to x square function. This actually goes via the origin. So here, if you look at it, it is crossing it more than once. So although this is a function, it is a many-to-one function, whereas this is a one-to-one. So be clear about the vertical line test and the horizontal line test. Don't get confused between these two. I think that's enough. Bye.